California, known for its innovation and breathtaking landscapes, is now becoming a hub of engineering marvels and urban transformation. In the midst of traffic-choked cities, sprawling suburbs, and an ongoing water crisis, a series of ambitious mega-projects are underway, promising to reshape the state's infrastructure and improve the lives of millions. From a $14 billion overhaul of Los Angeles International Airport to a $77 billion high-speed rail project spanning over 1,300 kilometers, the scale of these undertakings is staggering. Cutting-edge transit systems are set to connect sprawling cities more efficiently, drastically reducing commute times. High-speed trains will soon zip across the state, linking major cities in mere hours, and transforming how Californians travel. But it won't stop there. California is tackling its severe drought with an innovative $1.7 billion water management system, ensuring sustainable farming and urban water supply even during dry spells. These projects are set to redefine the Golden State. First on our list is the major transformation of one of the world's busiest airports, Los Angeles International Airport, LAX. For decades, LAX has been notorious for its traffic congestion, outdated terminals, and chaotic passenger experience. But change is in the air, and a monumental modernization project costing over $14 billion is set to redefine air travel in California. LAX's issues start well before you reach the terminals. Traffic jams are a daily ordeal, making the drive to the airport an exercise in patience. Once there, the struggle continues, with long lines for baggage drop, security, and minimal seating for waiting passengers. For years, LAX has been operating at near capacity, leading to frequent delays and crowded conditions. The Los Angeles World Airport LAWA organization, which oversees LAX, has taken on the challenge of overhauling the airport. The Modernization project aims to streamline operations, enhance passenger comfort, and improve traffic flow both in the air and on the ground. Central to this transformation are the extensive renovations of the airport's terminals and the introduction of the Automated People Mover, APM. Starting with the terminals, LAX is undergoing a complete makeover. Terminal 1, primarily used for Southwest Airlines, has seen significant improvements, including a new connection to Terminal 2, more ticket counters, baggage carousels, and a vertical core for the APM. Terminal 2, rebuilt in 1989 and renovated in 2017, is now seamlessly connected to Terminal 3, forming a combined facility primarily serving Delta Airlines. Terminal 3 was demolished and rebuilt with the new concourse and connection to the Tom Bradley International Terminal opening recently. The Tom Bradley International Terminal itself has been expanded, with new concourses opening in 2013 and 2015, and an additional midfield satellite concourse coming online in 2021. Future plans include further expansions to accommodate more international flights and enhance passenger flow. The entire project from Tom Bradley, including the satellite concourse, costs approximately $2 billion. One of the standout features of this modernization is the APM, a landside train designed to alleviate the notorious traffic congestion in LAX. Costing $2.25 billion, will have 6 stations along a 2.25-mile route, making it easier for passengers to move between terminals. The stations include 3 in the central terminal area and 3 external locations: the Intermodal Transportation Facility, ITF, West, ITF East, and a consolidated rental car facility. This new transport system promises to reduce the time spent navigating the airport and improve the overall passenger experience. The APM is set to open in April 2025. The ITF West, already completed, replaces the old economy parking lot with a state-of-the-art parking structure with 4,300 parking spaces. It serves as a primary pickup and drop-off location for shuttle buses and ride shares, which will significantly ease the congestion within the airport loop. The ITF East, connected to the Metro's Crenshaw/LAX line, will further enhance accessibility for passengers arriving by public transport. The ITF East is expected to be completed by the end of 2024. Terminal 9 and Concourse 0 are two ambitious projects slated for the future. Terminal 9 will be located across the Paul Vidal Boulevard and connected to the main terminal area via pedestrian bridges. It aims to add more gates and alleviate some of the pressure from the existing terminals. Concourse 0, linked to Terminal 1, will add new gates and improve passenger flow. These projects are expected to add around 27 new gates, significantly increasing capacity. Terminal 9 and Concourse 0 are targeted to be operational by 2028, just in time for the Los Angeles Olympics. The roadways around LAX are also getting a significant upgrade. New traffic patterns and roadway improvements will help manage the flow of vehicles better, especially with the addition of Terminal 9 and Concourse 0. These changes, costing about $490 million, are expected to make driving into and out of the airport less stressful. The roadway upgrades are scheduled to be completed by 2027, aligning with the opening of Terminal 9 and Concourse 0. LAX's modernization is a monumental task, but it is crucial for maintaining its status as a global aviation hub. Alright, let's dive into another transformative project: the removal of 4 hydroelectric dams from the Klamath River. This long-awaited endeavor, spanning southern Oregon and northern California, is set to reshape the river's ecosystem and restore over 2,000 acres of land. Buckle up, because this $450 million project is a game-changer. First, let's get the basics down. The Klamath River is California's second largest river by average discharge, draining a watershed of nearly 41,000 square kilometers. It's a crucial habitat for anadromous fish species like Chinook salmon, coho salmon, and steelhead trout, which migrate between freshwater rivers and the ocean. However, the river's natural flow has been impeded by 4 dams, collectively known as the Lower Klamath Project. These dams vary in size and shape. The farthest upstream is the J.C. Boyle Dam in Oregon, standing 21 meters tall and 211 meters long, built in 1958. Next up, we have the 38-meter tall, 126-meter long Copco No. 1 Dam, constructed in 1918. Just downstream is the smallest of the 4, Copco No. 2, at 10 meters high and 85 meters long, completed in 1925. Lastly, there's the Iron Gate Dam, an earth-filled structure 53 meters tall and 226 meters long, finished in 1962. These dams, now set for removal, have a combined install capacity of 163 million watts. The project aims to dismantle these barriers to restore fish access to hundreds of stream miles, some blocked for over a century. The dams have also created slower, warmer waters, causing algal blooms and impairing water quality. The removal process, kicking off in early 2024, follows a progressive design-build approach. In early March 2023, crews began enabling construction work, crucial for the drawdown of the reservoirs. This involves extensive road and bridge improvements to facilitate the movement of large construction equipment. At the Copco No. 1 Dam, a concrete work pad will be built on the downstream side, allowing for the drilling of a new 3-meter diameter adit through the dam's base. This tunnel, about 46 meters long, will be critical for draining the reservoir. Simultaneously, the smallest dam, Copco No. 2, will be removed using drilling and blasting techniques. For the Iron Gate Dam, an existing low-level tunnel will be reinforced to handle the hydraulic forces of the reservoir downstream. The design for these reinforcements considers various hydrological conditions, dry, average, and wet years to ensure robustness. The J.C. Boyle Dam will use existing culverts, initially constructed for water diversion during the dam's original build to drain the reservoir. These culverts, blocked by concrete step logs, will be blasted open when it's time to release the water. As the reservoirs are drawn down, a century's worth of accumulated sediment will be flushed out. The process will primarily utilize the power of water to mobilize and remove sediment, with some mechanical assistance as needed. The sediment management is crucial to prevent slumping or failures and to create favorable conditions for fish habitat. By November 24, all 4 dams and their associated structures should be fully dismantled. This will involve demolishing 76,000 cubic meters of concrete and 2,000 tons of steel, and excavating 993,000 cubic meters of material. These materials will be repurposed locally. For instance, earth removed from the J.C. Boyle Dam will be used to fill a large scour hole near the powerhouse, and the material from the Iron Gate Dam will be returned to its original borrow pit. Restoring the river's natural flow is only part of the plan. Approximately 2,300 hectares of land will undergo direct restoration work. This starts with seeding and erosion control on the former reservoir beds. An adaptive management approach will be taken, allowing the river to find its natural course over a year or 2 before light-touching restoration is applied to improve habitat conditions. The overarching goals are to restore fish passage and improve water quality. With the dams gone, fish can migrate freely, revitalizing fish populations and improving the overall ecosystem. Let's dive into Sacramento, where a major water infrastructure project is revolutionizing water management. Amid a historic drought, Sacramento Regional Water Waste Treatment Plant underwent a $1.7 billion transformation, integrating cutting-edge technology. Originally built in 1982, the plant processes 511 million liters of wastewater daily for 1.6 million people. In 2010, stricter regulations necessitated significant upgrades to reduce harmful chemicals. This led to the EchoWater Project, a decade-long overhaul that began in 2015. Construction involved 22 separate projects across the sprawling site. Over 40,000 tons of steel and 170,000 cubic meters of concrete were used, primarily in the new tertiary treatment facilities. These facilities consist of numerous concrete structures, pumping stations, and electrical installations crucial for advanced filtration and disinfection. At the heart of the plant is the Biological Nutrient Removal (BNR) facility. It features 8 massive basins with tubes that release oxygen into the wastewater, fostering bacteria that remove 99% of the ammonia and 89% of the nitrogen. The BNR facility is essential for ensuring the treated water meets environmental standards before being released into the Sacramento River. The tertiary treatment facilities are where the most critical processes occur. These facilities include multiple concrete structures where water is filtered and disinfected. The comprehensive upgrades make this plant one of the largest of its kind in the United States, capable of handling substantial wastewater volumes while ensuring compliance with strict regulations. Keeping the plant operational during construction was a complex task. A digital twin of the facility was created to manage this challenge. This virtual replica allowed designers and contractors to identify and resolve issues in real time, coordinating nearly 100,000 activities. The digital twin integrated 3D models in a 5D environment, linking them to schedules and budgets, which facilitated proactive decision-making and effective planning. With EchoWater Project now complete, the focus shifts to agricultural reuse. A new pump station and pipelines will transport the treated water to southern Sacramento County, irrigating up to 6,475 hectares of agricultural land and conservation areas. This initiative aims to reduce groundwater pumping, allowing aquifers to recover and promoting sustainable farming practices. The first phase is expected to be completed by 2025. The Sacramento Regional Wastewater Treatment Plant's upgrades not only improve water quality, but also positions the city to better handle future water shortages. Continuing our journey through California's transformative mega projects to the extensive tracks of the Bay Area Rapid Transit (BART) system. Over the years, BART has been a vital lifeline for commuters in the San Francisco Bay Area, connecting various cities with a reliable and efficient transit service. However, The demand for expanded coverage and enhanced service has led to ambitious plans for BART's future, with a series of projects aimed at extending its reach and modernizing its infrastructure. The expansion of BART is a monumental task that includes multiple phases, extensions, and upgrades, each with its own set of challenges and goals. The Silicon Valley extension, a key component of this project, seeks to extend BART's service from the Warm Springs station in Fremont to the Santa Clara Transit Center. This extension, split into two phases, represents a significant investment in the region's transit infrastructure. Phase 1 of the Silicon Valley extension, which extends BART's service to the Berryessa/North San Jose station, was completed in 2020 at a cost at $2.3 billion. This phase laid the groundwork for the next ambitious step, Phase 2. Scheduled to open in 2026, Phase 2 will further extend the line into downtown San Jose and Santa Clara, incorporating 3 new subway stations at 28th Street, Little Portugal, downtown San Jose, and Diridon/Arena, before surfacing and terminating at the Santa Clara Transit Center. The estimated cost for this phase is a staggering $4.7 billion. Unlike previous BART construction methods that employed cut and cover techniques, the San Jose subway segment will use a tunnel boring machine for most of the length to minimize disruptions. This approach will significantly reduce the impact on downtown San Jose. Through the station locations will still require substantial cut and cover construction, temporarily closing several blocks of Santa Clara Street and affecting VTA light rail operations. The Livermore extension is another ambitious project on BART's horizon. Initially planned to extend from Dublin/Pleasanton to Livermore, this project has seen various iterations and plans over the years. As of now, the preferred alignment involves building a station at I-508 and Isabel Avenue, with a possible express bus service connecting to the Vasco Road Ace Station. This extension is projected to cost around $1.6 billion, with a completion date tentatively set for 2026. Further enhancing the system's capacity and reliability is the proposed second Trans-Bay crossing, a visionary project that includes a new 4-bore tunnel beneath San Francisco Bay. This tunnel will add 2 additional tracks for BART and 2 conventional or high-speed rail, aiming to alleviate congestion in the existing Trans-Bay tube. The second crossing, part of the broader Link 21 program funded by Regional Measure 3, is currently in the feasibility study phase, with construction potentially starting in the next decade. The BART system, which uses diesel multiple units, DMUs, instead of traditional electric BART trains, is also set for expansion. This expansion, which provides a lower cost alternative to the conventional BART infrastructure, could extend service further into Oakley or Brentwood. The cost-effectiveness of eBART makes it an attractive option for expanding service without the massive expenditure associated with traditional BART lines. BART's long-term vision, dubbed BART Metro Vision, includes not only expansions but also significant upgrades to existing infrastructure. Key components of this vision include increasing station capacity, improving train frequency, and modernizing the train control system. These enhancements are crucial for ensuring that BART can meet further demand and continue to provide reliable service. In addition to these expansions, several infill stations are planned to improve service on existing lines. Notable among these is the Iverington Station in Fremont, which is expected to open by 2026. This station will provide much-needed connectivity in a rapidly growing area and is part of BART's ongoing efforts to enhance service within its operational core. From the bustling tracks of the BART expansion, we now turn our attention to the transformative project in Los Angeles, the East San Fernando Valley Light Rail Transit Project. This project aims to reshape public transportation in the San Fernando Valley, offering a more efficient and sustainable alternative for the region's commuters. The East San Fernando Valley Light Rail Transit Project proposes constructing a 9.2-mile light rail line running north-south along Van Nuys Boulevard and San Fernando Road. This line will feature 14 stations, connecting key points in the valley, with a planned completion date for the first phase in 2021. The project is a significant part of the Los Angeles Metro long-range plan. Starting at the Sylmar/San Fernando station, the rail line will provide a crucial link to the Metrolink Antelope Valley line. From there, it will travel southeast along San Fernando Road for 2.5 miles before turning south on Van Nuys Boulevard for another 5 miles, eventually reaching the G-Line's Van Nuys station. Along the way, the rail will intersect with other vital transit lines, including the Ventura Country Line Amtrak routes, enhancing connectivity across the region. The light rail line is planned to run at grade along the median, utilizing standard gauge tracks and powered by an overhead line with a 750-volt DC electrification. This approach was chosen to minimize costs and disruption, avoiding the need for expensive tunneling. The entire project, estimated to cost $3.635 billion for the first phase, represents a substantial investment in the future of San Fernando Valley's transportation infrastructure. The route of the new light rail echoes the historic Pacific Electric San Fernando line, which ran from 1911 to 1952 before being converted to bus service. This modern revival of the century-old transit corridor is designed to meet the needs of today's commuters, providing a faster and more reliable alternative to the heavily congested roadways. Construction is set to proceed in 2 phases. The first phase, which will run from the Van Nuys G-Line station to San Fernando Road, is expected to begin in mid-2024. This segment alone will cost an estimated $3.635 billion. By 2023, Metro had initiated further studies to address potential conflicts with Metrolink's plans to double-track the Antelope Valley line, ensuring that the new light rail will integrate smoothly with existing planned rail infrastructure. Utility work along the line commenced in December 2022, making the first visible steps toward the project's realization. One significant intermediate stop on the line will be the Van Nuys Metrolink station. Here, passengers can transfer to the Ventura Country Line, Amtrak routes, and the proposed Sepulveda Transit Corridor, which aims to connect the San Fernando Valley with Los Angeles' west side. This station will be a vital hub, enhancing the connectivity and convenience of the light rail for daily commuters. As we look forward to 2031, the completion of the East San Fernando Valley Light Rail Transit Project promises to bring transformative change to one of Los Angeles' most dynamic regions. Let's dive into another critical project reshaping California: the restoration of the Salton Sea. This vast inland sail line lake, formed in 1905 due to a Colorado River levee breach, has become an environmental challenge. Yet significant efforts are underway to address its issues and revitalize the area. So, what's the big deal with the Salton Sea? It covers about 890 square kilometers, and while it was once a booming tourist spot, it's now struggling with high salinity, pollution, and receding water levels. Agriculture runoff has only made things worse, creating a toxic mix that's a real health hazard for nearby communities. As the water recedes, it leaves behind a dusty lakebed, which gets whipped up by the wind and spreads harmful chemicals. Enter the state's ambitious 10-year plan to restore the Salton Sea by 2028. With around $400 million, this plan covers 30,000 acres of exposed lakebed, focusing on reducing dust and creating habitats. One of the standout projects is the Species Conservation Habitat, the SCH. At the southern end of the sea, we're talking about 1,660 hectares of interconnected ponds designed to support fish and bird populations. This is one of the largest habitat restoration efforts in the region and should be wrapped up in a few years. Now let's zoom in on Bombay Beach, where another significant project is taking place. Here they're covering 688 hectares of exposed shoreline with native plants like cattails and bulrushes. These plants help stabilize the soil and reduce dust emissions. The first phase is already complete, with more planned to ensure long-term sustainability. It's a win-win, better air quality and a safe haven for migratory birds. But wait, there's more. Smaller projects also play a crucial role. One cool initiative is the multi-use pathway around the northern shore of the Salton Sea. This 4-kilometer trail will connect the North Shore to the historic yacht club and the state park. It'll feature a pedestrian bridge, shade structures and added vegetation to help keep the pesky dust down. Plus, it will be a great spot for locals to enjoy some outdoor recreation. Speaking of dust, advanced air quality sensors have been installed around the Salton Sea to monitor pollutants like hydrogen sulfide, nitrogen dioxide, and ground-level ozone. These sensors give scientists valuable data to understand and mitigate health impacts. It's all about making the area safer for everyone living nearby. One of the fascinating developments around the Salton Sea is the natural wetlands that have popped up as the water recedes. These wetlands cover thousands of acres and are formed by runoff and underground springs. They provide crucial habitats for migratory birds and help reduce toxic dust. Protecting and expanding these wetlands is key to maintaining ecological balance and supporting wildlife. And get this, geothermal plants near the Salton Sea are now being repurposed for lithium extraction. These plants harness the Earth's heat to generate energy, and the salty brine they use is packed with lithium. The Department of Energy estimates there's enough lithium here to make over 375 million electric vehicle batteries. That's a potential economic boom for the region. One exciting new initiative is the North Lake Pilot Demonstration Project. The plan is to create a 3-meter-high berm to form a 65-hectare lake at the northern edge of the Salton Sea. They'll use water from the Coachella Valley Water District to maintain a stable, managed environment for recreational activities like boating and kayaking, while also creating new habitats for birds and fish. It's still in the early stages, but it's a promising step towards bringing back some of the sea's former glory. By 2025, they aim to complete the permitting process for the emerging wetlands, with the entire 10-year plan set for full implementation by 2028. These combined efforts are setting the stage for a revitalized and sustainable Salton Sea, balancing ecological needs with community health and economic growth. Welcome to the visionary transformation of Santa Clara. The related Santa Clara project, spanning 97 hectares, is set to redefine urban living with its blend of office spaces, residential units, retail, entertainment, and expansive green spaces. This massive undertaking, with a project cost of approximately $8 billion, is poised to become a landmark development in the heart of Santa Clara. The first phase, known as the Tasman Block, will feature a 39,950 square meter office complex, 4,650 square meters of retail space, a 480-room business hotel, 200 apartments, and an underground parking garage, with a capacity of 1,900 spaces. This phase alone sets the tone for a vibrant and integrated urban environment, combining commercial, residential, and hospitality elements. Upon completion, related Santa Clara will encompass a staggering 854,700 square meters of developed space. This includes 156,077 square meters dedicated to residential units, with 170 units designed as affordable housing. The project will also include 529,547 square meters of prime office space and 65,032 square meters of hotel space, providing ample accommodation options. Additionally, 74,322 square meters will be allocated for retail, restaurants, and entertainment venues, including a global food market that promises to be a culinary hub. The development features significant green spaces, with a 14.2 hectare park and an additional 10 hectares of open space, ensuring ample recreational areas for residents and visitors. These green spaces are designed to blend seamlessly with the urban environment, offering a refreshing escape from the city bustle. An adjacent development, Tasman East, will further enhance the area by adding 4,500 residential units across 16 hectares. This extension underscores the comprehensive nature of the related Santa Clara project, aiming to create a holistic and vibrant community. Construction details reveal a meticulous approach to urban development. The project involves creating new roads, extensive landscaping, and upgrading infrastructure systems to support the high-density urban environment. The development will feature advanced parking solutions with both surfaces and multi-story structures designed to meet the area's growing needs. The phased approach ensures continuous development and improvement, with each segment carefully planned to maintain high standards and smooth progress. By the end of the project, Santa Clara will boost a new urban hub, combining modern living spaces with functional design and abundant recreational areas. If you enjoyed this video, please like, subscribe, and leave a comment below. Don't forget to turn on notifications so you never miss an update on the latest in construction and engineering.